Right. In the last experiment, we ended with collecting data, all right, for 0.61 millivolts and 1.81 millivolts when it comes to uh, this particular this particular rod rotating. And we set our origin and our scale for both of them. And now we just want to insert our data. So you'll notice that we have 0.61, we have 1.81 here, okay? And then we're going to have our interpolation as well as our extrapolation just calculated for us. So let's go ahead and grab that data. In fact, let's just open this. No, we need to put our data into this folder, and then we'll go about bringing the data over. So let's go back to 1.81. And I would rather start off with 0.61 millivolts since that's where we started. And I'm just going to take the data file as usual. We're going to go to graphical as usual. And then we're going to format this as a table and move it over to Microsoft Excel. So I could say open in. And of course, here's our Microsoft Excel folder. And I am going to definitely put it into Dropbox. So here's that data. I can tell that this is the right data by looking up here. 61 millivolts, convert and edit. I'm going to go back into Dropbox, go back into the appropriate folder here, go to angular velocity versus voltage, and save that right there. It's a CMBL file. So now we want to do the same thing for the next experiment, which is 1.81 millivolts data file. See, we actually have 3, 1, 2, 3 humps. Okay, let's format that table. So this is not the right file, but this one is. So we can check by looking at 1.81. Going to convert and edit that. And we're just going to put this into the appropriate Dropbox folder. And just save it right there. Now, what do we need? If we go back into our folder, and that's what I would rather do. I would rather open up our folder, go to Dropbox, go into our template here. So it still has last name, first name. You guys make sure you change that. And under the first template, the 0.61 millivolts, we want to collect the X and the Y position, and the X velocity and the Y velocity. So let's go ahead and get that. We should stay in the same folder. So all we have to do is just select on this particular data set. And of course, I want to see what I'm collecting before I collect it. So we don't need time. Make sure you hide that. But we do need the X and Y, and the X velocity and the Y velocity. So I'm just going to select all of that. I'm going to copy that, and then we're going to go back to our template here. And we're just going to paste over. Now it's going to change the color. So that's kind of good because when it doesn't copy over, the color will be there. So I'm going to say paste. And if we go down, you'll see that we are missing a few calculations. So I'm just going to fill and drag that down because those are calculations. Then I'll go up and look at the average angular velocity. And I'm going to select on this column what we want. We want H:H. What happens when you select H colon H? Well, you get all of the data. Okay, so that's our average. The next one is going to be 1.81. So let's go back and grab that. And we're going to do the same thing here. Then we're going to go back into our template here and paste that. So notice we're in the appropriate tab. You want to make sure you're in the appropriate tab and drag over and paste. So let's go and look. It's saying division by 0 here. So it's something happening. The reason why that's happening is because all of the data did not come down. When that happens, we need to go ahead and select this piece and then just delete it. If we go back up, you'll see that our angular velocity has been calculated. And of course, I want to select on the entire column of H, so that's H colon H, and it'll select all of the data. You may have had it already, but in this way, I'm pretty sure. So now, with those two there, the interpolation should be calculated for us immediately and are produced for us. So all I did was I set some increments. I did the same technique that we've been doing. If you go to this top file or this top, cell, A2, you'll see that I have C13, which is right here, minus C2. Those are that's our voltage. And I just incremented in between the voltages. And I took those increments and I added them the same way we've done before. So that's C2 plus A2 and on and on and on. The difference is I also incremented the angular velocity for each one of these. So you'll see that it's the same kind of thing. We take our D13 minus our D2. You might say, well, where does this information come from? Well, if we select on it, you'll see that we just put this information in because we measured these two off of our device as far as the voltage. But the angular velocity was an actual calculation that was done on sheet 1 and sheet 2 here, or the 1.8 millivolt sheet. And so now we produce a voltage versus angular velocity graph. And so now we should be able to predict what will happen between these 2 points. So let's just say we pick 1 volt here, 1 millivolt, then we should get around 7.5 radians per second. That's the idea, that we develop this relationship and we can study it, we can understand it. And then if I go over to extrapolation, you'll notice that the same phenomena is taking, or the same thing is taking place. We just have an equation here. So now instead of us looking at 1, we can look at 1.02, and we can see what y is going to be. Y, again, is going to be the angular velocity, and x is the voltage. So we just put the voltage in millivolts here, and we'll get ourselves an angular velocity. And in the next experiment, we will utilize this information. That's the end of this experiment. Make sure you take your link from Dropbox and upload it or save it to the STEM initiative.